Hello, and welcome to Taking Control of Cyber Supply Chain Security. If you're joining us live, our speakers are in the Slido chat discussion area right now answering questions. They're also hosting a fabulous supply chain capture the flag directly after this presentation. If you have any audio or video issues, click the technical support button below. I'd now like to turn it over to Beau Woods and Dr. Allan Friedman for the presentation.
Thank you very much, Britta. I'm Beau Woods with I Am the Cavalry.
And I'm Allan Friedman from NTIA.
Hey, Allan, get a load of this. What do you think that is?
That looks like a prop from a Star Trek knockoff from the 1950s. So maybe it's a death ray?
Oh, you're very close. It's actually a life ray. This is an MRI that hospitals use to get an inside view into a patient and find out what's hurting them. If you're a defender at a hospital, how do you think you would figure out what vulnerabilities might exist in this type of device?
Ooh. Maybe I'd hire a hacker like you just to try to pen test it, see what they can find.
Well, that's a good thought. Having worked in healthcare, though, I can tell you these types of things don't respond so well to penetration tests or vulnerability assessments. Sometimes they can fall over, stop working, give bad results. So what if, like an MRI machine, you could peer into the device and see what software it's running?
That'd be pretty useful. Do we need special equipment for that?
You might need special equipment. On a quick internet search, one of the things you can see running in some of these devices, MRI devices and other hospital equipment, is something made by this company. Now, do you recognize this company?
I don't know that organization, no.
Well, they look pretty trustworthy. They say they make medical devices, and when it matters, it runs on Wind River. Will it help if I gave you this overlay?
Now, that is something that's familiar to me. That's a real-time operating system, right?
That is a real-time operating system. And what do you know about vulnerabilities in this real-time operating system that may also exist in the medical device we just showed?
I seem to recall last summer that there was a whole bunch of attention paid to this particular product.
That's right. The Urgent 11 set of vulnerabilities that with a few internet packets, an adversary could completely take over a device running on VxWorks, running that operating system. All right, if you like that game, let's play a slightly different one. Do you recognize this?
Well, it's been a really long time since I was in a plane, unfortunately, but that looks like a really big plane.
It does look like a really big plane. In fact, it's an Airbus A380, one of Airbus's signature airplanes that flies in dozens of fleets around the world. Now, what do you think we can tell about this if we examine its underlying software?
Well, I think, like the medical device, we probably don't want to try to hack it, especially while we're on the plane.
Oh, that's right. You definitely don't want to hack it when you're on the plane, or even tweet that you're going to hack it when you're on the plane. But we can do something similar. So as you see here on the Green Hills website, they feature the Airbus 380 as one of the technologies that their software is in. So what do you think we might know about Green Hills software and what vulnerabilities it has that are then in the Airbus 380?
Well, I'm sure since it's probably different than the vulnerabilities in VxWorks, right?
You would assume that, but actually, it also has the Urgent 11 vulnerabilities. The Green Hills software has Urgent 11 vulnerabilities. Surprising, shocking even, you may say. Why is that? Well, Allan, have you heard of this company?
I don't know. Sort of sounds like a generic mid-aughts tech company.
Yep, you would be right. This company, called Interpeak, stood up in the early 2000s and was purchased by VxWorks in 2006. Before it was bought by VxWorks, it licensed its technology, its IP stack called IPNet, to all of these different companies, including Green Hills Software. So this is how you get Urgent 11 vulnerabilities persistent throughout the supply chain. It's why a software package by one company that was used in a software package by another company rolled into a software package that was eventually deployed on an airplane and a medical device can pervade all of these different systems and impact everything that's downstream.
And that's what we want to talk about today, is this notion of a software supply chain. The software that you're using is built on more software and built on more software, and that's great. But it helps us get better software, more efficient development. But the risks that we're facing are growing, and the supply chains are getting longer, and in fact, sometimes more opaque rather than less opaque. So we want to introduce to you the idea of a software bill of materials as a new and emerging tool that can help you understand the risks in your software supply chain. We're going to tell you that they are coming and that you can help be a part of shaping what it looks like for your organization, your industry, your sector.
So what do we mean when we talk about supply chain exactly? Well, this is a late model car.
It's a lot nicer car than I can afford on a government salary, I'll tell you that much.
It's a lot nicer than I can afford on a private sector salary too. But some people can afford it. And if we could, then we would be able to see all the different parts and components of this car that are made by third parties. It's part of the extended supply chain of this one single vehicle. Now, a lot of these components or elements that go into the car have a software component. So if you pick any of these out, the smart opener, the mechanical pump, the front and rear seat belts even, a lot of these components have software elements as a part of them. Probably the most familiar one that most of us think about in cars is the infotainment unit, the thing that sits right up front and that now has an app store and Wi-Fi with 5G connectivity connected to it. But what does that look like when you look all the way down the supply chain? When we think about all of the different elements and the potential vulnerabilities. Well, that supply chain can be pretty deep. And it can also be pretty opaque. It can go to many different levels and layers, as we saw with Interpeak and the IPnet software. It can go way down the rabbit hole. It can also be, as we saw with the Interpeak, if you were involved in looking for some of those Urgent 11 vulnerabilities, it's hard to know where those vulnerabilities existed because it's hard to see which package had them. Any package that has a vulnerability tends to pass that vulnerability down the supply chain to the ultimate product that you might buy and put in your environment to operate, or that you might sell to your customers to operate. While it can be overwhelming, we want to give you a very simple framework to understand some of these supply chain risks. So starting at the top, you have supplier facilitated risk. Now, this might be what you typically think of as third-party supplier risk. The people who are helping you design your website, who are coming in to clean after hours and have access to your physical premises. The folks who have access to your HVAC equipment so that they can maintain it over time. This is what we mean by supplier facilitated risk.
And Beau, there are actually 2 great talks at AJP this year devoted to thinking about assessment and risk from third-party software and third-party service providers.
That's great. The next type of risk we want to talk about is counterfeit risk. Now, this is particularly harmful in hardware components, but it can also apply to software components as well. So hardware has firmware on it. Sometimes with the hardware, you'll have remarked chips that didn't pass inspection the first try. So they might remark them as if they passed, or they might take substandard components, mark them as higher grade, and then sell them on a gray market. Or you might have software that comes bundled with some of the packages, some of the things that you get, that is unlicensed, which may mean it doesn't get security updates, or it may mean that there's some inferior capabilities in it, or security issues that had to go into developing the breaks that allowed people to get around the licensing regime. Or it could come with backdoors, Trojan horses, deliberately implanted in the software that gets carried into the final product. We also want to talk about or think about malicious taint. Now, this is what you might think of when you think of an intentional subversion, often by a nation state, of the technology that you're buying. But in those cases, it tends to be very expensive, and the adversary has to have a privileged position within the supply chain in order to make these types of security risks manifest. So it can be 6 figures and 6 months to get an implant in a device, which for most organizations probably isn't worth worrying too much about. For other organizations, it is. And several organizations spend millions of dollars a year trying to look for this type of malicious taint. The last type we want to talk about and cover in this framework is called unintended taint. You might know this as known but unmitigated vulnerabilities in supply, development, deployment, configuration. These are things that typically we only treat at the operational layer. But if we look at them through a supply chain lens, we actually have a lot more tools that we can use to pull on in order to decrease costs and optimize risk for your organization. So we're going to examine those through this talk and how you can understand those better and how you can treat those.
So what can we do about this? One of the challenges of thinking about supply chain risk is supply chain isn't some magical slot that most organizations have. It actually touches on different roles that we all wear, different hats that we all wear inside an organization. And so we're going to share 3 different perspectives of thinking about supply chain risk. First, a lot of us make software. And there, the concern, as Beau was talking about, is worrying about vulnerabilities in our components. So am I delivering something to my customer if I make software that is actually vulnerable today? So I need to have some visibility into my supply chain. But this is also something that can be seen as just part of good production, part of a standard proper supply chain. The same way that if I make a car, I want to pay attention to the components that I'm shipping. Similarly, if I'm making software, I want to know what's in there. This allows me to better manage my code base, execute allowed policies or excluded policies, and similarly pass along that information downstream. The other area in supply chain is how we choose software. Maybe we're buying commercial software. Maybe we're selecting a key open source component to fulfill a role in our organization. One of the first questions we should be asking is, are there known vulnerabilities? Out of the box, is this going to put my organization potentially at risk? This, in turn, can allow me to do a more targeted security analysis, can help me understand software integration, and also it's a way of thinking about the maturity of the organization that I'm either buying from or selecting from. And of course, almost all of us are operating some software on our networks or in our cloud environments. And there we have a very simple, straightforward question. Is there a risk today? And more importantly, in the future, when we discover one of these issues that Beau was just talking about, can we quickly and easily determine, are we affected? And if we are affected, maybe there's a patch available, that's great. If there isn't a patch available yet, knowing about it can actually help us take other mitigations. We can tune our intrusion detection system. We can segment our network. We can work with our threat intelligence provider to help us understand what risks might be targeting us personally. All 3 of these roles are critical, and they all depend on one key thing that we need in our software supply chain, which is transparency. How do we get transparency? We get transparency through this idea of a software bill of materials. So what is software bill of materials? Well, one way to think about it is it's an ingredient label. Some of you know that when you go to the store, there are notices about allergens. There are lots of people who are allergic to nuts, so the package on my piece of candy might say, may contain nuts. Wouldn't it be nice if my software told me, hey, you know what? It may contain struts. So when I say SBOM, what does it look like? Well, it's not that complicated. One way to think about it is a dependency graph. This is the piece of software I'm using. Here's a toy example, say a company called Cloud Pets, which turns out in their supply chain, they were using a database that if anyone had looked, they would have seen had no security, even though it had data from kids and families. But in this case, we're not going to look at this. We're going to look at the toy example. We're going to say, oh, listen, Acme Appliance is built on 2 components, Bingo Buffer and Bob's Browser. Bob's Browser, in turn, contains Carol's compression engine. The other thing to notice about this is this allows us to see what data we don't know. So for example, we know that Carol's compression engine doesn't have any further components. That's fine. We don't need to worry about that. We just watch that. Bingo buffer, depending on my risk tolerance, maybe I want to know what's inside it. We're just being able to document just what's the software component so that we can make the appropriate risk-based decision. Just a graph. So how deep do we want this data? To think about the basics, we want just at least all of the top-level includes, all of the software that you're directly calling. And the vision that the community is slowly coming up with is to saying, we want to use recursion to get us down there. So have your top-level includes and ask for their includes, and then we'll be able to make a best faith effort to actually have some visibility. Now, when I say we, what do I mean? There's an ongoing global cross-sector effort that's trying to establish some of the basic norms and practices around this. The scope is really the entire supply chain. Starting with the open source community, we've got folks from the Linux Foundation, the Apache Foundation, Oasis involved, through middleware, commercial software, embedded in IoT, and of course, perhaps most important, customers, people using software today who need this information. We're also making sure that the scope is cross-sector. We don't want to have separate solutions for different types of companies because we all use the same software. Because we have such a broad scope, we're trying to frame it quite narrowly. We're just looking at software. There's a lot of other information we may want. The vision is to integrate it into those other efforts. We're just focusing on the software dependencies. So why would we want to do this? Why should we SBOM? Well, I've talked about some of the different perspectives, but let's look about how this can help the community. We talk about one of the magical properties in cybersecurity of resiliency, and SBOM is a great example where it can give us resiliency. If we discover a flaw way up my supply chain today, I may not learn about it until it percolates down. Someone has to patch, that patch has to get rolled in, that patch has to get rolled in. It could take quite some time before I know about it. There's nothing magical about changing people's speed of patching once we have visibility and through transparency. But with an SBOM, I can take action today if I believe I'm at risk through other mitigations while I'm waiting. And I can also try to drive that upstream. So, Beau, let me ask you a question. If you have to choose between two different open source products to use or two open source libraries to use in your product, one of them has a handful of vulnerabilities in it. Maybe it's got 2 CVEs. And the other one never had a CVE. Which one are you going to put in your product?
I think, probably the one that's never had a CVE, right?
Well, it'd be really nice to think that never having a CVE means no vulnerabilities. But I'd argue it's the exact opposite. If you have a CVE, that means it's actually a fairly mature project. They know how to receive vulnerability information from a hacker like you. They know how to get a CVE number, and they can put it in a vulnerability database so that we all know about it. They're good citizens. It could be that the one that's never had a CVE has just never had a vulnerability, or it could be that as an organization, they don't know how to work with the broader software ecosystem. Having an SBOM allows us to have visibility upstream and actually reward organizations that are thinking about it. But maybe you don't care about the bigger ecosystem, right? You're here to make money and serve your customers. Well, it turns out that having visibility just makes simple financial sense. The product security director from a giant company told us that having visibility could save them 100,000 man-hours. Why? Because whenever there's a risk, they have to work across all of the different product families that are all quite siloed today. And then they have to coordinate it with their customers. Having the visibility and the transparency could really help. So if we're going to do this, how are we going to do it? We didn't want to create yet another standard. That's the last thing folks need, is a new thing to adopt. We wanted to build on what's already out there. And the good news is that there are 2, now 2.5, data formats that are able to implement SBOM. SPDX comes out of the Linux Foundation. It's built for licensing, but it can be used to capture SBOM data. And similarly, the SWID tag, which is an ISO standard, an international standard. And the vision here is also it can capture this data and share it down. We're not interested in saying we have to pick one. In fact, quite the opposite. We're going to make sure that there's one that we can translate across them. We're not going to pick a winner, but making sure that we can all use the same fields to convey the same data. And you can see that, listen, we're not looking for too much. What's the supplier? What's the product? What's the version? And then a hash, so we're talking about the same thing. The last thing I want to flag for ongoing work is some proof of concept work that's happening, because it's not just enough to talk about it. We need to show that it's valuable. And over the past year, some of the biggest hospitals in the United States have gotten together with some of the medical device manufacturers that are making popular products to show that the manufacturers can generate the data and the hospitals can actually integrate this data into their risk. And one of the things that we're really proud of is in the middle of the world's largest public health crisis, we have hospitals still prioritizing this exercise. It's even being led by the CISO of New York Presbyterian in New York City, one of the epicenters of the current crisis in America. This has the priorities, and it's pretty rare. Hey, Beau, is it common for the healthcare sector to be leading in cybersecurity?
Having worked in the healthcare sector for 3 years, I can tell you, no, it's not common.
So what are the next steps in our process? Right now, as we've brought together this global community, we're refining and extending the model. We're trying to tackle some of the remaining engineering issues. We want to integrate this into other areas that are more focused on high assurance, such as, say, 5G or transportation, where we need to know what's in our software. We also want to make this easier and cheaper for you. And so we've got folks from the open source community and the security vendor community collecting tools that can do this today, and also acknowledging what are the tools that we need to make sure that we can have this working for you. And we're thinking about awareness and adoption. There are more proof of concept exercises percolating in different sectors. This is interesting to you, please reach out. And ultimately, I think we're going to see this in some draft contract language, so you can start keeping an eye out for this.
Yeah, and just having an SBOM or creating one, taking receipt of one, using it, isn't going to get all of your software supply chain issues solved. So there are a lot of other things. Many of them are related to SBOM. Many of them can be supported by SBOM or enabled by SBOM. What do those look like? Well, the first one is pretty straightforward: software updates. In the software industry, we've known and used about those for decades. Some of the other organizations and some of the other industries are not quite as far along. So you might be surprised, but there are still today in 2020 devices and systems that you can buy that are not software updatable when security issues pop up, or where some pretty critical components of those systems are not software updatable. You have to replace the individual component, or you have to replace the entire software package or entire device. Asking or getting to understand the manufacturer's software supply supported lifetime will help you understand what your responsibilities are and when you might need to look at replacing it. So ask manufacturers, ask vendors how long they're going to support security updates at a minimum. Usually there's an internal development lifecycle process that they have. If they can't tell you, that should be a flag right there that it may be that they don't know, or they're not going to support it for very long. At a very minimum, if you're not informed about what that support lifetime looks like, you can't adequately plan for when you need to replace it, or how to operate safely and securely after that date, or even when you'll need to start adding more protections to these devices so that you can secure them if you choose to still operate them. Secondly, I want to point out some model contract language, model procurement language. The Edison Electric Institute and the Mayo Clinic both have sets of model procurement language you can use for supply chain security. Now, I'm most familiar with the Mayo Clinic's versions, and in it, they ask for things like a software bill of materials. They ask for things like supported software lifetimes and update lifetimes. They ask about certain things and certain concepts that mature manufacturers will be really easily able to address, and less mature organizations might have to think a little bit harder. But essentially, if they can't tell you some of these components and some of the security questions that these procurement language documents ask or put into the contract, then it indicates that you might have to do more on your side, increasing your cost of secure operation.
Another thing that we can do once we have visibility into our supply chain is actually monitor that supply chain. So if you know that you're using a certain open source component, you can say, or a certain commercial component, you can start to do targeted analysis. You can loop it into your threat intelligence. There are a number of folks in the market, they're starting to do this more, which will actually monitor it to make sure that there isn't an intentional backdoor or that new vulnerabilities haven't been discovered.
And one of the things that we couldn't end this talk without bringing up is the metaphorical elephant in the room that rarely gets talked about. The idea of software liability and the idea of new liability models that might help organizations and ecosystems understand where some of the trade-offs are in accountabilities and responsibilities and roles throughout the supply chain and chain of operations. If you don't know who's on the hook for what type of security mechanisms or security processes, then it's hard to know who has to do something, and it slows down response once you know something needs to be done. So what to do next? All right, imagine that the talk is over. Don't close the window yet, but in a few minutes, after you get done with the supply chain CTF, close the window, go send out an email to your procurement officer. Probably they're trying to do the same thing you are. Increase the quality of things that your organization gets, decrease the cost, and ensure that they're able to be integrated safely and securely. So help them help you. Find out what they need to better help both of you be successful. Secondly, ask sellers if they provide SBOMs. Ask sellers if they provide other security information that you can look at, because if they aren't providing this, again, it tells you a little bit of something about how they secure their organizations. A major Global 100 bank in the United States today asks, and for the past 5 to 7 years has been asking for SBOMs, not to scrutinize them necessarily, but in particular as an indicator that a certain organization's maturity level in security might be insufficient. It tells them that they're going to have to do more on the bank side to increase security. So they're going to ask for a discount of 10 to 20%. That can be a really, really valuable negotiation technique. Third, consider accountability and responsibility. Who does what when, and what happens if they don't? Having these discussions, looking in the Mayo Clinic's procurement language, you can see how they have decided to come down on some of these issues. And you can use that as a roadmap and a model for yourselves. Next, brainstorm how you're going to respond to new vulnerabilities or new types of supply chain issues. Run some tabletop exercises, maybe one where you have no software bill of materials and one where you have a software bill of materials. See what the difference would be in your response time and capabilities.
And cost.
And cost, that's right. As Allan mentioned earlier, there's an open dialogue going on, cross-sector, cross-supply chains, international. One of the venues where you can get involved is through the NTIA working group process and their multi-stakeholder convenings. So if you can attend and pop into these industry-led events where you join the conversation, there's a link down here in the bottom, ntia.gov/software transparency. Go there, find out how you can get involved and how you can learn from them. And finally, we have some resources that you can look at. If you want to know more about the broader issue of software supply chain, the Atlantic Council has done a great job of collecting some data so that you can see the general trend and show your management that this is a growing issue with real data behind it. And of course, this is how to get in touch with me and learn more about the NTIA effort. And with that, we're done with our presentation. Thank you very much, and stay tuned for the Supply Chain CTF.
Thanks so much.